Now, a man wishes to swim across a 36-metre wide river. The river flows at a velocity of 2 metres parallel to straight banks, and he can only swim at 1. So essentially the man isn't getting straight across. Have we all agreed with that? So here's the river going at 2. Now what we're generally assuming is the man is going to aim up this way. So he thinks he's going this way, and he's going to use 1, and he's going to use angle alpha. Is that okay? But realistically, what is actually happening to him? He can't go straight because he's not fast enough. So what's happening? He's getting whipped downstream. Is that okay? Trying to aim for here actually ends up down this way. And we call this angle what? Theta. Is that alright? Now, we're using the medium of rivers, okay? Or water. So, is it phi BW? Sorry, man, isn't it? Is it phi MW or phi WM? Is it the velocity of man in water, or is it the velocity of the water in the man? Huh? Yeah. Okay. Now, velocity of man in the water. Now, what we need to remember is that the velocity of the man in the water is how fast he goes in still water. Is that alright? So, velocity of man in water is velocity of man minus velocity of water, and the actual velocity of the man is the man in the water, man in still water, plus the velocity of the water. That's what that means there. The actual velocity of a man to a stationary observer on the shoreline is the velocity of the man in still water plus the actual velocity of the water. Does that make sense to everybody? Alright. Now, here's what we're going to do next. Is we're going to break it up into its components. We know that velocity of water is 2I. And now we've got to break up the man. So, would everybody happy with a 1 cos alpha and 1 sine alpha? 1 cos alpha, 1 sine alpha. So, velocity of man is minus cos alpha I plus sine alpha J. Is that alright with you guys? Now, okay. Now, let's figure out let's figure out the actual velocity of the man. So add the two of them together. Oh, sorry, velocity of man in water. Add the two of them together, and we get 2 minus cos alpha I, and then plus, what's a sine alpha times J? Yeah. Now, if we colour code this blue part here, that's equivalent to your I value you get drifted down stream. If we talk about the J value here, that's the opposite value of how you're getting drifted downstream. So tan theta is the yellow one divided by the blue one. So therefore tan theta is equal to sine alpha divided by 2 minus cos alpha. Is that okay with you guys? Now, to prove it's a maximum, what do we need to do here? What did we do the last day? We differentiated, didn't we? Using already existing techniques we already know. Do I have to differentiate the left? No. I just need to find out for what value is this here a maximum. Alright? You can even call it y if you want. You can just say temporarily I'll call it y. And what I want to figure out is what is its maximum. Okay? So if u equals sine alpha, what's du d alpha? I think it's just cos alpha. You're getting integration mixed up. It's very easy to do. And 2 minus cos alpha. Did anybody get sine alpha?
Yes.
Because it's minus sine alpha, which is plus sine alpha. Now we're going to do the quotient rule for differentiation. We all hope you know what the quotient rule is. Usually v du dx minus u dv dx all over v squared. So let's do that. So we're going to get 2 minus cos alpha. Du dx is, or du d alpha is cos alpha. And then minus u, which is sine alpha, times another sine alpha, all over 2 minus cos alpha squared. Alright, it's a max when it's equal to 0, isn't it? Because it's a turning point. It's a turning point, which means the slope equals 0. So your slope, which is your first derivative, has to equal 0 at maximum values. So, what do we get here then? We're going to get 2, oh interesting, 2 cos alpha, and it's going to be minus cos squared alpha. And like the question we did the last day, what is minus cos squared alpha sine alpha? What is it? It's minus 1, isn't it? So it's 2 cos alpha minus 1 divided by the denominator. Now that denominator doesn't matter, because it's the numerator that causes it to be equal to 0. So you're able to get 2 cos alpha equals 1, cos alpha equals a half, alpha equals 60 degrees when you inverse it. Is there another part to this question? What is the question? What does it say? The time to cross the river, is it? Here's an interesting thing. Could you have found the time taken to cross the river without actually successfully doing this part? Yeah, just remember that, okay? If you get a different answer than 60, just use the answer they told you should get, okay? So if I go back to the start here, and for the velocity of the man, all I'm going to do is enter in 60. So go all the way back up here, so no bother, 60s. So it's going to be 2 minus cos 60 I plus sine 60j. Pretty sure that's root 3 over 2. Pretty sure the other one's going to be 3 over 2. It's going to be 2 take away a half, which is 3 over 2. Which component am I concerned with? Am I concerned with the yellow part or the blue part? I only care about the yellow part because all I have to do is go up. How far is it? 36 meters? All I have to do is cover 36 meters. So it's going to be 36 meters divided by root 3 over 2. And that's the time taken. And 36 divided by root 3 over 2 is 6 root 2, which is lovely. Imagine doing all that right and then just doing that at the end.
Well, you know you were wrong. The
Alright, good man, Mick. So we pay you the big money. Now, is everybody happy with 24 root 3? Alright, who got it? Alright.